Day 18 of 60, and today we're deleting your Bastion host. Here's the scenario every cloud security engineer dreads: an attacker steals an SSH key, and now they've got persistent access to your fleet with zero audit trail. Nobody knows who logged in, what they ran, or when. AWS Systems Manager solves this at the architecture level, not with another firewall rule, but by removing the inbound port entirely. By the end of this video you'll kill SSH bastions, patch hundreds of instances automatically, and lock down remote execution with least privilege. Let's build it. First, why does Session Manager need no inbound ports? The magic is the SSM agent. It runs on your instance and calls outbound to 3 AWS endpoints, SSM, messages, and EC2 messages. The connection is initiated from inside your VPC, so your security group can have zero inbound rules. For a truly private fleet, you create VPC interface endpoints for those three services, and your instances never touch the internet. No Bastion, no public IP, no port 22. The attack surface for remote access basically disappears. The instance just needs an IAM instance profile with the Amazon SSM Managed Instance Core policy attached. Now let's start a session. From the console, you pick your instance and click Start Session. You're in a shell, no keys exchanged. But the real power is the CLI. Run AWS SSM Start Session, target I0 ABC 123. That drops you straight into the instance. Here's what makes security teams happy: every keystroke can be logged. You configure a Session Manager Preferences document to stream shell history to a CloudWatch log group and an S3 bucket. So now every command, attributed to a specific IAM principal, timestamped, is searchable. That's the win engineers miss. SSM isn't just access, it's a full audit trail. Let's prove it. Open CloudWatch Logs Insights against your session log group and run a query. Fields at timestamp, at message filter at message like sudo sort at timestamp desk. Instantly you see every privileged command run, who ran it, and when. Want everything a specific IAM role did? Filter on the role's session identifier. During an incident this turns hours of guesswork into a 30-second query. Pipe those logs into Security Hub and you've got remote access activity feeding your central findings dashboard. No agent forwarders, no syslog scraping, it's native. Next, Patch Manager. Manually SSHing to patch fleets is where audit gaps are born. Instead you build a patch baseline, a rule that says, auto-approve critical and important security updates 7 days after release, or tighter, within 72 hours for critical CVEs. You tag instances with a patch group, like patch group equals production web, and attach a maintenance window that runs AWS run patch baseline on a schedule. The instances patch themselves overnight. Then you gate traffic on compliance. A Lambda reads SSM compliance data, and any instance reporting failed patch status gets deregistered from its ALB target group. Non-compliant boxes stop receiving production traffic automatically. Then there's run command for fleet-wide execution, and this is where least privilege matters most. Run command lets you execute a document across hundreds of instances at once. But you don't want every engineer running arbitrary scripts on production. So you scope the IAM policy with condition keys. Allow SSM, send command only when SSM, resource tag / environment equals production and only for approved document names. Now an engineer can run your approved remediation document on tagged prod instances, but nothing else. Every invocation returns a command ID you record for audit. Approved roles, approved documents, approved targets, that's enforced least privilege at scale. Let's close the loop with self-healing infrastructure using SSM automation. You write a runbook with AWS, execute AWS API steps. Picture a config rule that flags an S3 bucket with public access enabled. That finding triggers an automation runbook that calls put public access block to slam the bucket shut, then fires an SNS notification with the before and after state. The misconfiguration fixes itself before an attacker ever finds it. Wire automation runbooks to config rules and your guardrails stop being alerts you read tomorrow, they become remediations that already happened. Finally, verify with SSM inventory. It reports every instance's agent version and patch state, so you can confirm your whole fleet is actually managed and compliant, and that data feeds Security Hub. Day 18 done. Key takeaway: Systems Manager turns reactive firefighting into proactive, policy-driven control, no bastions, full audit trails, and infrastructure that heals itself. Subscribe for Day 19.